Imagine shrinking, smaller than a grain of sand, smaller than a single cell, smaller than an atom. Now imagine looking inside that atom. You expect something solid, something mechanical, something ordinary. But instead, reality begins to dissolve. For most of history, we believed matter was solid. A rock feels solid. A table feels solid. Your body feels solid. It seems obvious, but physics has a habit of humiliating obvious ideas. When scientists first looked inside the atom, they imagined a tiny solar system. Protons and neutrons at the center. Electrons orbiting like planets. Simple, clean, logical. But the deeper they looked, the stranger it became. An atom is mostly empty space. If the nucleus were a marble in the center of a football stadium, the electrons would be tiny specks near the outer seats. Everything in between? Almost nothing. Not air, not gas. Nothing. And yet that nothing builds everything. Then came the real shock. Electrons do not behave like solid particles. Sometimes they act like particles. Sometimes they act like waves. And which one you see depends on how you look. In the double-slit experiment, electrons fired one at a time create an interference pattern, a pattern only waves should make. But the moment you try to observe which path they take, the wave disappears. The electron becomes a particle again. It's as if reality waits for you to look. Richard Feynman once said, "The double-slit experiment contains the only mystery of quantum mechanics." He wasn't exaggerating, because inside an atom, you don't find objects. You find probabilities. An electron does not exist in one definite place until it is measured. Before measurement, it is a cloud of possibilities. Not here, not there, everywhere it could be. Only when interaction happens does one outcome appear. Something strange happens when you look. Reality sharpens, but physics does not explain what truly causes this collapse. The math works perfectly, but the meaning, still mysterious. And here's the unsettling truth. Everything around you, the chair you're sitting on, the phone in your hand, your own body, is made of atoms. Atoms made of electrons. Electrons that are not solid things, but vibrations. According to quantum field theory, particles are not little objects. They are excitations in invisible fields, like ripples on an ocean. An electron is not a tiny ball in space. It is a vibration of the electron field. When you look inside an atom, you don't find tiny billiard balls. You find waves, fields, probabilities. Even empty space isn't empty. Virtual particles flicker in and out of existence. Energy fluctuates. The vacuum seethes with activity. The atom is not a miniature solar system. It is a storm, a dynamic event, stable only in appearance. And yet, quantum theory works. Its predictions are accurate to astonishing precision, more precise than any scientific theory in history. So when Feynman said, "Nobody truly understands quantum mechanics," he wasn't admitting defeat. He was acknowledging wonder. Because the closer we look, the less solid reality becomes. Matter becomes vibration. Certainty becomes probability. Objects become relationships. And here is the most mind-bending part. You are made of this. Every thought, every memory, every breath, your existence rests on quantum uncertainty. The solid world you experience emerges from something profoundly non-solid. When you look inside an atom, you expect smaller pieces of reality. Instead, you find that reality itself dissolves into mathematics and possibility. Maybe atoms aren't strange. Maybe our intuition is. Our brains evolved to survive, not to understand quantum fields. The universe isn't built the way it feels. And that is the real mystery. Because the atom is not a tiny machine. It is a window into a universe far stranger than common sense ever imagined. And in that sense, Feynman was right.